Welcome. I will continue with the domain and the range of a function. Okay, now I should give a classical definition of a function. Okay, so a function, as I said earlier on or previously, I said you have an input and you get the output. Okay, so a function is defined from a set of real numbers to a set of real numbers. Okay, so when you have real numbers in one dimension, you get real numbers in one dimension. Okay, so f is defined from r to r. Okay, from the set of real numbers to real numbers. So when you take x from the set of real numbers, you expect to have f of x from the set of real numbers. Okay, so the definition is, for every x a member of real numbers, there exists at least f of x, which is also a real number. Okay, member of real numbers. Okay, in some terms, you'll find people define a function like a relation from a set A to a set B. When you take an element from a set A, you expect to have an element from set B. So for every element which is a member of A, there exists at least f of x, which is a member of B, where A is a subset of real numbers and B is a subset of real numbers. So when we're dealing with functions, we are dealing with real numbers. Okay, set of real numbers, a set of real numbers. Okay, so here we have the set of inputs. Okay, the set of inputs is called a domain. Okay, generally that set contains the elements of A. Okay, which is x. Okay, and then the set of output is called the range or the image, and that set is generally B. Okay, and it contains the elements of B. Okay, which are the outputs of A. Okay, so that's the definition of a set. So now let's find the range. Okay, what is the range and the domain? Okay, the domain is the interval at which the function is defined. Okay, it's the interval or the values which defines the function. Okay, and then these are the inputs, and then the result of the inputs, that's the range. Okay, so we normally have intervals and sets to define domain. Okay, so let's find the domain of this function. Let's find the set of a domain. A function is defined from r to r. Okay, this is it, from real numbers to real numbers. We have x from the set of real numbers. Then we expect to have f of x from the set of real numbers, where f of x is equal to x. A function where f of x is equal to x is called an identity function. Okay, where the input is equal to the output. Okay, so this is called the identity or the unit function. The output and the input are the same. So now let's find the domain. Okay, so the domain here for x, a member of R, there exists at least f of x, which is a member of R. The domain set here is x such that x is a member of R. Okay, x is a member of real numbers. When you look at here, f of x is equal to x, any number you put here, this function is defined. For instance, if you say f of 0, you're going to get 0. Okay, if you want to put f of 0.5, you're going to get 0.5 because x maps x, f of x goes to x. Okay, so here you just put the input and then you get the output. So in this case, all the values of x, okay? All the values of x are real numbers, okay? That's the domain. And then what is the range, okay? As I said, this one is the unit function. The domain and the range is the same, okay? Because when you put 0 here, you expect to get 0 because f of x is equal to x. And of course, when you put minus 2, you expect to get minus 2. When you put half, you expect to get half. When you pick 5, f of 5 is equal to 5. F of square root of 2 is equal to square root of 2, okay? Because this is a unit function or the identity function, okay? Yeah, so the range and the domain are the same, okay? So the domain is x such that x is a member of R, and the range is x such that f of x is a member of R, okay? Where f of x is equal to x, okay? Actually, it's the same. Now, let's see another example. Example 2, okay? Find the range and the domain, okay, of the function. So solution. So the domain is a set which defines the function, okay? So now, here, you look at this. F of x is equal to the square root of x squared minus 1. When you have something like square root of a, okay, for the properties of square roots, a is always greater than or equal to 0 because the square root of a negative is not real, okay? It is not real. It's not a real number, okay? It is not real. It's not real. Okay, that's a different concept. That's a complex number. So for a real number, because we're talking about a set of real number, for a real number, square root of a is always greater than or equal to 0. Of course, square root of 0 is 0, and so on and so forth. So we take the same concept. The square root of x squared minus 1 brackets should be greater than or equal to 0. Not should be, must be, okay? Greater than or equal to 0. And then we square both sides, okay? When we square both sides, here, we square both sides. The square and the square root will cancel, so we remain with x squared minus 1 is greater than or equal to 0. 0 squared is 0, okay? Now, x squared is greater than or equal to 1 when we take 1 to the other side, okay? So the square root of x squared is greater than or equal to positive or negative the square root of 1, okay, when we take the square of both sides, okay? So in this case, we have this x is greater than or equal to positive or minus 1, okay? But this is a bit confusing because x is greater than 1 or x is less than 1, okay? If you have, like, you can do it, it's more easier. Like, if you have square root of x, okay? Square root of x is the same as this, okay? Yeah. Square root of x is the same as absolute value of x, all right? Yeah. So if we say the square root of x squared is greater than or equal to the absolute value of 1, okay? And then from there, this one will cancel, so x is greater than or equal to absolute value of 1, okay? Absolute value of 1. And then within absolute values, you have something like, if you have a less than 1, okay, it means you have minus 1 is less than a less than 1, okay? And if you have a is greater than 1, okay, it's the same as minus 1, okay, is greater than a greater than 1, okay? So this actually is the absolute, okay, absolute value. So if we say, let's say, what was that? X squared, okay, square root of x squared is greater than or equal to the absolute value of 1. So here x is greater than or equal to the absolute value of 1, and then minus 1 is okay, minus 1 is greater than or equal to x, okay, greater than or equal to 1, okay. So in this case x is greater than or equal to 1, and x is less than or equal to 1, okay. Yeah, so that's the domain, okay. So the domain is greater than or equal to 1, x is greater than or equal to 1, or x is less than or equal to 1, and we write that in set builder notation as x a member of R such that x is greater than 1 or x is less than greater than or equal to less than or equal to minus 1. I forgot that, okay. So now what is the range? The range is x a member of R such that f of x is greater than or equal to 0, because f of x is equal to the square root of x squared minus 1. Everything which is in the square root is either 0 or going above, okay. It's greater than or equal to 0. So since f of x, we get f of x when we perform the operation on this square root, so we are very sure that this expression won't give us anything less than 0, okay. So f of x is greater than or equal to 0, all right. Now for the other example, we have been given the domain minus 2 is less than or equal to x less than or equal to 2. It's a domain of the function. Let's find the range of the function, okay. Now from this function, okay, from this function we have the minimum is minus 2, okay, and the maximum is 2, okay. So f of minus 2 is minus 2 squared, okay. Of course, minus 2 times minus 2 is positive 4, and the maximum f of 2 is 2 times 2, okay, which is 4, okay. But within the interval we have 0, okay. Within the interval we have 0, and f of 0 will be equal to 0, okay. So we have seen that the minimum will be from 0 and the maximum will be 4, because this one gives us 4 and this one gives us 4, okay. But when we take the number here which gives us the minimum, and which is 0, 0 squared is 0, okay. So the range will be between 0 and 4, okay. So the range will be x a member of R such that 0 is less than or equal to f of x less than or equal to 4, okay. That one will be seen on the graph, okay. On the graph you understand very well what we are talking about. So sometimes you can have the domain and then you ask to find the range. There are many ways of which you're going to grasp the points, but we're just doing the first step, okay. Now find the range and the domain, okay. In this case we have been given a function which has the quotient on the left side, okay. So f of x is equal to 1 minus f of x is equal to 1 over x minus 1, okay. Then find the range and the domain of the function, okay. Now I've given a definition, simple definition. A number which is p over q, okay, is a real number, and this number is called a rational number, where p and q are integers and q is not equal to 0, okay. Because if q is equal to 0, you're going to have the expression like which is like p over 0, okay, like when p is 1, okay, 1 over 0, which is undefined, okay. Any number over 0 is undefined. So in this similar manner, this number won't be 0, must not be 0, should always be non-zero. Okay, so the domain is, okay, first of all, I write the function f of x is equal to 1 over x minus 1. Then the denominator must not be equal to 0, because if the denominator is 0, this will be 1 over 0, and the number will be undefined. Okay, so x minus 1 is not equal to 0. Okay, so now we treat the operation, okay, like we take -1 to the other side of the sign. Okay, so negative will become positive when it crosses the sign, so it will be x is not equal to 1. Okay, so what is the domain? The domain set is all values of x. Okay, they are real numbers, all numbers within the number line. Okay, all numbers. Okay, x is a member of real numbers such that x is not equal to 1. X won't be just 1, but otherwise the function is defined for all values of x apart from 1. Okay, just 1 is an exception. So this is the domain. Now the range will be you go to the main function, you cross multiply. Okay, so you're gonna have x minus 1 brackets times f of x is equal to 1. So you make x a subject to the formula. Okay, x minus 1 is equal to 1 over f of x when you divide f of x both sides. So x is equal to, when minus 1 crosses the equal sign, becomes positive, x is equal to 1 plus 1 over f of x. Okay, now as I said, 1 over f of x, this denominator must not be equal to 0. So that tells us that f of x is not equal to 0. So the range set will be x, a member of real numbers, f of x not equal to 0. Okay, f of x is not equal to 0. So this will be the range. Okay, as we proceed, we will know what to do with this. Of course, we will have to take the inverse of function, and of course plotting the graphs, and of course these things are called asymptotes. Okay, these are asymptotes, and these are asymptotes. Okay, yeah, thank you. I hope you are fine.